Again, welcome to Java Programming Language CS102, lecture number 1, an overview of computers and programming languages. In these lectures, we're going to cover the concept of computers. We are going to learn about computers. Also, we are going to explore the hardware and the software component of a computer system. Normally, a computer consists of, again, the hardware and the software components. Also, we're going to learn about the language of a computer and examine how Java program is processed. So computers have greatly affected our daily lives, helping us to complete many tasks. Example would be online tasks such as taking classes online, shopping online, banking online. So computer programs, which are softwares, are designed specifically for each task. Again, we have a software that we can use to do a banking activities. Again, to shop online. These are all different types of softwares. So software is created with programming languages such as Java. In this course, again, we are going to learn how to use the Java programming language to develop any type of software application we can think about. So Java is an example of a programming language. Now, first we'll go through the elements of a computer system. As we mentioned earlier, a computer has two components, the hardware and also the software. So normally the hardware will be the physical component of the computer. Hardware is something that we can feel it, we can touch it. So example will be the central processing unit, which we normally call the CPU. And also a main memory. These are all, again, a physical component inside the computer system. We also have a storage devices, such as the hard drive or flash drive, external storage devices. So this is an example of a central processing unit and main memory concept. So we are assuming the green rectangle box shape is our computer system. In a computer system, we have the central processing unit. We also have the main memory. We also have our secondary storage device, which can be the hard drive or external storage device, such as the flash drive, floppy disk, etc. We also have the input device and also the output device. So normally a computer system will consist of an input device, such as a keyboard or mouse. This device allows us to input the data into the computer. And also we have the central processing unit, which is the main, we will say the brain of the computer. So normally when we input the data into a computer system, the CPU is going to process it for us. But normally when we input the data again, the data will be stored in our main memory, unless we install it or we directly install it into our secondary storage device. And so, for example, when we start our computer, the operating system, normally a computer consists of two types of software. The operating system is very important. That is the software that manages the hardware component or even interact with the hardware. Then we have the application software, which are the different types of software that perform a specific task. Example will be, if I want to use the internet, then I need a web browser. A web browser such as Chrome or Internet Explorer, Firefox are all application software. Or if I want to create a resume, I may need a Microsoft Word document. This is also application software. Now, if I use a Microsoft Word to create a resume and I want to print out the resume, I have to send that information to the operating system because application software cannot interact with any hardware. And that's the work of operating system. So the operating system will interact with the printer to print our resume. So every computer system consists of an operating system and also the application software. Now, anytime we are doing any work, for example, I want to create my resume, the resume will be loaded into my main memory. So any work we do in our computer, always we do it from the main memory. The main memory is where the CPU can access our data or a program. So when we start Microsoft Word program, it will be loaded into the main memory. When we start our computer, the booting process, the operating system must be loaded into the main memory. Normally, we have three types of memory. The largest is the main memory. Then we also have the cache. A cache will be a memory that is close to the CPU. Then we have the register, which is a memory inside the CPU. So normally the data or the items, the tags that the CPU is processing, that item or the data is stored in the register. So we may go more details on this as time goes on. Our Apple devices, after we process our information finish, we want to see our result, then the result can be displayed in an Apple device. So an example of an Apple device can be our monitor. Our input device, as we said, can be the keyboard or the mouse. Secondary storage can be the hard drive or flash drive, etc. And our main memory normally consists of what we call the cells or boxes. Each box has its own unique address. Here, for simplicity, we gave the number value as the address of the cell, which is in this case 1000, 1001. This will be the address of each cell. And the content of the cell, we can see 54 and A, etc. So as we said, the main memory consists of cells, the other sequence of cells. And each cell again have its own unique address. And the main memory normally directly connected to the CPU. So the CPU can access the data from the main memory, but not from the secondary storage device. So here we say all programs must be brought into main memory before execution. So even when we start our computer, the booting process means the operating system must be loaded into the main memory. So when the power is turned off, everything in the main memory is lost. So sometimes we call the main memory a volatile. The volatile means the data will be available or the contents in the memory is always there when the power is on. When the power is turned off, everything is lost. Then the secondary storage device. And this is a device that we can store our data for permanent. So it's provided permanent storage for information. Whether the computer is on or off, the data is still there permanent. Example of, again, a secondary storage device can be the hard drive, floppy disk, flash memory, zip, and even the CD-ROMs, and also tapes. Input device normally allow us to input the data into our computer system. So here we say devices that feed data and the computer programs into computers. So example will be keyboard, the mouse. Also sometimes secondary storage device can act as a keyboard. A very good example will be a video camera. Can act as an input. If I attach the video camera to a computer, I can download movies or images into my computer. An Apple device is the device normally we can display our results. Or we can, the printer also is an Apple device, we can print our data or information from the computer. So Apple devices, devices that the computer uses to display results. So a very good example will be the printer, the monitor, and also speakers. Secondary storage also can act as an Apple device. So a camera can act as an Apple device and also as an input device. Because with camera, there's a screen, I can see information, or I can download an information such as movies or images to a computer. So this example of our input and output devices, we have the monitor output device. Input device can be the mouse or keyboard. Printer also is our output device. The flash drive also is our secondary storage device. So next we move to the software. So we finish with the hardware. So as we said, the hardware is the physical component of the computer. Every physical component, from input devices to output devices to the memory to the CPU, these are all hardware devices. Now a software consists of a program written to perform a specific task. The software is not a physical device. Normally, a software will be stored in a hardware component, such as the secondary storage device. So it's a program. So we have two types of programs. The system programs, or we may say the system software. These are the software that can interact with the computer hardware. They can interact with the computer hardware. An example with the operating system, or utility programs such as antivirus software, or software that we can use to clean our disk, etc. Then we have the application programs or the application software. These are the software that again perform a specific task. So again, system programs control the computer. A very good example is the operating system. That's why, again, the booting process operating system is first loaded into the main memory, because the operating system controls the hardware resources, the coordinator. So operating system monitors overall activity of the computer and provides services. An example of services can be memory management, also input and output devices, activities such as storage management. The activities can be if the computer is a multi-processing or multi-task system, then the operating system is the one that have to do all the scheduling of the CPU time to all the tasks or the process. Application software, again, is a software that normally perform a specific task, also called the application program. Normally it's written using programming language. The same thing applies to the system software, also is written by using programming language. So as we said, application programs or software perform a specific task. We have thousands of different types of application software, and it must run by the operating system. OS stands for operating system. So example programs can be a word processor, which we can use to create any document, or a spreadsheet. We can use it to create any spreadsheet or accounting data. Games, computer games for entertainment, and etc. Web browsers, etc. So the language of a computer is machine language. The computer only understands machine language. Machine language is in the binary form or binary numeric system. 0, 1, 0, 1. 0 means off, 1 means on. So machine language, the most basic language of a computer. It's a sequence of zeros and ones. Also, every computer directly understands its own machine language. So each computer platform has its own machine language concepts, especially the CPU. A bit is a binary digit. So the 10-bit means 0 or 1, binary digit. And a byte normally is a sequence of 8 bits. So 8 bits represent a byte. And this is how data is stored in the computer. Every single character, symbol, etc. is a byte. That's why if we are going to buy a storage device in a store, or we want to know the capacity of any storage device, the unit is always in byte. For example, 1 gigabyte. 1 gigabyte means that storage device can store up to 1 billion characters, symbols, etc. So this is example, a byte means 8 bits. Kilobyte means, normally we will say kilobyte means 1,000 bytes. But in computer system, a kilobyte means 2 to the power 10, which roughly gives us 1,024 bytes. But approximately we always say 1,000 bytes. A megabyte also the same concept. Mega means million, so megabyte means 1 million. But actually, it's more than that. It's 2 to the power 20, which is 1,048,576. But again, we always approximate it as million. The same thing applies to the gigabyte is 1 billion, which is normally supposed to be 1,073,741,824, which is 2 to the power 30. So a byte is 8 bits. A kilobyte will be 2 to the power 10. Megabyte, 2 to the power 20. Gigabyte, 2 to the power 30. Then we have terabyte, 2 to the power 40, which is in trillions. Then we have petabyte and exabyte and zettabyte. So high-level programming languages, and that's what we are going to study. A high-level programming language is a programming language that we normally can say it almost in English in a higher form. Computer doesn't understand high-level programming language, such as Java, C++, and Visual. Java, as we can see, most of the language is in English terms. So that's why we have something special, a special program called a compiler or interpreter. When we write our Java program, an interpreter will interpret it into a byte code, and the byte code will convert it to, again, a machine language, which normally we have the Java virtual machine. We may discuss about that later. But a high-level programming language is close to a spoken language, mostly in English words. Computers doesn't understand it, so we have to either translate it or interpret it to machine language. So example of a high-level programming language is BASIC. These are one of the oldest earlier high-level programming language, Fortran, COBOL, C++, and also Java, which is our main course. We also have a Python, Perl language, and so many high-level languages. So to run a Java program, as we say, a Java program is a high-level programming language. In order to run a Java program, again, first, we have to have the Java instructions. So Java instructions need to be translated into an intermediate language, which we call the bytecode. Because again, Java language is almost English, high-level language. Computer doesn't understand it. So first we need some special program or special software that will translate it to a bytecode. Then the bytecode will be interpreted into a particular machine language. And normally this computer will have something called a Java virtual machine, JVM, which does this work for us. So a compiler is a program that translates a program written in a high-level language into equivalent machine language. In the case of Java, again, this machine language, again, is called a bytecode. And then we need a Java virtual machine, which is the JVM. This is a special hypothetical computer developed to make a Java programs machine independent. So any computer, whether it's a mainframe, whether it's a cell phone, desktop, if that computer have a JVM, then it can be able to run a Java bytecode or Java program. This is what makes Java very famous in terms of internet application or online applications, because we know on the internet, there are different types of computers, different architectural platforms, from cell phone to mainframe computers. Excuse me. And these computers all are connected in the internet system. So with a JVM, it makes the Java neutral platform is neutral. Java can be run in any computer platform as far as there's a JVM with that computer. A language like C++ or C Basic doesn't have this concept. So every platform, we have to write a special program to support it. So this is a Java, this course is a Java program. So we may focus more on Java. We are not going to discuss much about the hardware components. Those are different classes, mostly in the computer architectural class. Those materials are discussed. Also, we are not going to discuss about the operating system. We have a special course for operating system, which we go more detail, because we know operating system is one of the complex software. It has so many features. So there's a special course for that. So this is an example of a Java program. We have a public class. So when we see the blue text, it means it's a special word that Java understands. And we normally call it a reserved word or the keyword. So when I'm going to write a Java program, the first thing I need is my main class. The name of the main class is the same as the name of the file. In this course, we are going to start with the Java standalone application. So this is a Java application, standalone application program. We also have a Java applets, Java servlets, etc. So we start with the keyword public and class, everything in lowercase, then our main class name. And later on, we shall go through the rules of how we can name our classes, variables, etc. So we have our main class name. Here, the name is my first Java program. So this means the file name will be my first Java program.java. Java program or Java files, the extension is .java, lowercase, J-A-V-A. Then we need a main method. In a standalone application, the main method is where the execution takes place. So we have another keyword, public static void. Our main method name is called main, and it takes only one argument of string type array. So this is a string array, then args, one argument. Next, we have the system.out.println. In Java, if we want to print something on our screen, this is a console application, more or less like DOS. We have system.out.println. And we may discuss the meaning of all these keywords and also what the main program is in later chapters. So if we run this program, first we are going to compile it, then we run it. Our output will be my first Java program. So this is the output, my first Java program. Now what we have in the parentheses here, my first Java program, is called a string. Always a string will be in a double quotation. So whatever is in a double quotation with system.out.println is going to be printed on our screen. Later on, we're going to have a lectures on graphical user interface. We can use the Java also to create a window applications, graphical user interface to interact with the Windows. So this is our first Java program. The output will be my first Java program. Again, in our later lectures, we will go through all the keywords, the structure. So how do we process a Java program? This is where we want to be more focused on. Now, as we said, we have two types of Java programs. In this course, we are going to focus on only applications. We have applications and also applets. So the source program is what is written in high-level language. So this is my source program right now, and I have to run it. First, I have to translate it, then run it. So first, we write our source program using Java program. Then the next step, we have what we call the loader. Loader normally will transfer the compile code, which is the byte code, into main memory. Then we have the interpreter. Interpreter will read and translate each byte code instruction into machine language, then execute it. So in the interpreter with the JVM, which is the Java Virtual Machine, will execute. Then when it executes, again, this is when the computer will understand. Execution of a source file means we are converting the program from English form of language to machine language so that the computer will understand. So that's the steps. First, we write our source program. Most of the loader and the interpreter, we don't see it. This normally happens in the system. But of course, we have to click on either to build or to compile, etc. And we will again run the program soon. So this is the step again. We need an editor to write our source code. Then we are going to compile it. Now, if the compiler detects any error, most of the time, the error that the compiler will detect is called a syntax error. That is a grammatical error. For example, we saw the Java program. The Java program ends with a semicolon. So we have the Java program and expression end with a semicolon. If I remove this semicolon, or I forget to have the semicolon, or when we open a curly brace, we need to close it. So we can see we open it twice, we close twice. We open for the main class, we open for the main method. This is called the block. So everything in the main, which is only one statement here, is only seen if we have another method. This will be only seen by this method. Other method will not see it. So now if we forget to close any of the main method or the main class, this will be a syntax error. So when we compile, we are going to get a syntax error. Now, if there's no error, then the compiler will convert it to a byte code. Then we need a loader, load to the main memory with a library file. A library file is a special built-in packages, consists of classes and methods. For example, we say system.out.println. Println or print is a method which is part of inside the library file. So we don't have to write a method to print something. So this library file will be loaded, then the interpreter will do its work. Interpret to a machine language so the computer will understand it. So next is the program analysis coding execution cycle. Now in programming language, we know the main goal of writing a code is to solve a problem. Even if it's for entertainment, it's still solving a problem. So the first thing, we need to analyze our problem. Normally, this is a very complex topic which normally is covered in software engineering courses. Normally, we may have something we call requirement analysis. We have what we call the functional requirement and non-functional requirement. A functional requirement will be what the software is going to do, the functions. Non-functional requirement will be the quality of the software. Example, we are developing a software for a non-profit organization. So security is not an issue, but speed is an issue. So this will be a non-functional requirement. And we try and choose the right program or the right way to write this code so that the speed will be very good. But security issue, we don't concern. Now, if I'm writing a program and security is an issue, then that's what I'm going to focus on. So I may relax on speed issue if we have to balance the two. So those will be non-functional, the quality of the software. So when we go through our requirement analysis, we have to know what should be the input to the software, the program, what should be an output. Now, our goal is to design our algorithm that can make it possible to transform the input to an output. So the algorithm will be a step-by-step problem-solving process. The steps must be in a sequential order or linear order. What must be done first must be done first. Then what must be done second must be done second. So you have to be in sequential, a step-by-step problem-solving process in which a solution is arrived at in a finite amount of time. So first we need to analyze the problem. As we said, normally analyzing the problem, we want to know what is the input, what should be the output, what items we need, such as a variable, method, object, etc. Then we outline the problem and the solution requirement. Next, we need to design the algorithm to solve the problem. After we design finish, then we can implement the algorithm. Implement the algorithm means writing the code. In our case, it will be Java program to solve the problem. So I would say most of our homework, when you get the question first, make sure you understand the question. The hardest part about programming courses is not the program itself. It's easy to learn Java program, what we should use to print, what we should use to get an input, etc. It's easy. But understanding the problem and be able to use Java to solve the problem is the hardest part. So first thing we need to do, analyze the problem. Make sure you understand the problem before you move to the next step to design the algorithm to solve the problem. If you can design the algorithm to solve the problem, then next step now is to use the Java program to write the code. Then we're going to run the code to verify that the algorithm works. So if I write a program that will find the sum of two numbers, if I enter 7 and 3, and it gives me 73, that means there's something wrong. Maybe it's joining the 7 and 3 together instead of adding them together. So we need to verify. And also we need to maintain the program by using and also improving it. And that's why most of the time, many software companies such as Microsoft, they may have one software that they have many versions of it. Example would be Microsoft Office from 1995 version to 2016. And for a few years to come, we may have a new version. So this is the problem analysis, coding, and execution cycle. We have a problem. We're going to analyze our problem. If we analyze our problem, we write the algorithm. If we make some mistake or we find some faults, then we have to go back for the analysis, check the analysis. Other than that, if the algorithm is good, then we write the code. If we write the code and there's a problem, then we have to go back to either the algorithm or the analysis. So we can see that the steps are interactive. We can move up and go back. If there's no problem, we compile. If there's an error, we go back to the coding. So you can see that in the compiler session, we don't go back to analysis no more because the compiler only will detect a syntax error, the error with the Java program, the grammatical error of the Java program. Now, if there's no error, then we have a bytecode. Then we need a loader to get our library files, etc., to interpret it. And if there's no error, then we get a result. If there's an error, then we have to go back, maybe the coding. So there's two types of programming methodologies, the two basic approaches. One is the structured design. This is our old method, NDR method. And I would say the classical method. Then we have the object-oriented design. So with the structured design, And normally a problem will be divided into smaller subproblems. Then each subproblem is solved. Then later we combine all the subproblems together, have one solution. So we can see that the structured design is focused on writing the solving the problem. In this case, writing the functions for each task and solve the problems. But with object-oriented design, we more focus on objects. So this program is a collection of interacting objects. And we have a special chapter for this topic, which we're going to cover in the future. So normally an object consists of two things, the data and operations. And we can create, before we create an object, we have to create what we call the class. So example of an object can be, let's say we have employee object. The data for employee object can be maybe the employee hourly rate, how many hours he work, his last name, address. Then the operations that we can do on employee can be, we can calculate salary, we can calculate how many hours he work for the week. If there's any late, we can check if there's a late. If it's absent, these are all the operations. So any object may have two things. The characteristics of the object, in this case, the employee, can be his height, can be his weight, and can be his salary, his hourly rate, the number of hours, etc. Operation can be, we can calculate his height, or we can measure his height, salary, etc. So again, we may go details on object-oriented programming. What is a class? What is inheritance, polymorphism, encapsulations? Those are the three main building blocks of object-oriented programming: encapsulations, inheritance, and polymorphism. These three things make our program more secured and also reducing the code in terms of inheritance, and be able to write a code that can do more than one thing at a time, which is the polymorphism. So the steps in object-oriented design, we first identify objects. Normally when you have a problem, you can identify the object by looking at the nouns. Some of the nouns may be good, some may not be good. So for example, if I want to create a program that will be managing a video rental store, then one of the objects can be video. Another object can be employee, because employees may interact with the video. And another object can be customers. So you can see that all the objects are nouns. Then the verbs will be the actions. Maybe employee can check for availability of video, or customer can rent out, or can bring back the video, etc. So when we identify the object, then we form the basis of the solution. Then we determine how this object interacts, how employee may interact with the video, and how customer may interact. Maybe employee may not take a video from store, but may receive it. Customer may take video from the store, etc. So that will be the conclusion of our first lectures. Again, these lectures cover the concept of computers, what is a computer in a basic form, and also what is a Java high-level languages. And so I'll see you in the next lectures, which we are going to start with the Java program, the basic elementary Java.